Hello everyone, welcome back to our channel. In today's video, we are going to dive into the world of Python and explore how to build an image classifier. Whether you are a beginner or have some programming experience, this tutorial is designed to help you understand the fundamentals. So before we proceed further, let's create the setup to install some libraries that is required to build our image classifier. So first we open the new terminal, and then we will run some commands to install the setup that is required. So first we use Python pip install opencv, which is required as which will install the cv2 library in our system, and then we are moving towards numpy. If basically I have already installed these required libraries in my environment, so if you don't have these libraries in your environment, please first you need to install them. So mm, the third one is matplotlib, and the last one is tensorflow. TensorFlow. So it is already installed. Now we just clear it. Now what we need to do, we begin by importing the necessary libraries. We have the first we have is opencv, which is basically the cv2. Basically this library is for image processing. And the second one we have is numpy for numerical operations. And the third one we have is matplotlib for visualization basically, and we are using the PLT to basically to plot our images into our console and into our screen. And the third one we have is TensorFlow with Keras. Basically, we are using Keras dataset, which is predefined here. So we can basically uh, import the sample images, and basically we must have a look at how the sample images looks like, so that we can build our image classifier according to the sample images that by using the Keras sample dataset. All right. So before proceeding further, we use to create two variables called the training images and training labels, and testing images and testing labels. So basically we are loading our dataset. Uh, we are using the CIFAR 10 dataset, which contains 6032 dimension 32 color images belonging to 10 different classes. So basically, here we are loading our dataset, and then we basically divide the training and testing images with 255 each. So basically here we are loading the training and testing images along with their corresponding labels. We also normalize pixel values to be between 0 and 1, which is a common practice in deep learning. All right. So and then it is important to know that the class name associates with our data set. So basically, we are defining the 10 names of different things of the class names, which we are going to basically see the sample images. All right. So basically, the first one is plane, car, bird, cat, and we have deer, dog, frog, horse, ship, and truck. All right. So frog and horse, ship, and truck. Yes. So we have defined a list of class names to make it easier to interpret the results of our image classifier. Now let's visualize some sample images for the dataset. So to visualize the sample images, we have created the for loop, and then we are using the PLT subplot libraries and define the dimensions and conditions in order to visualize these dataset that we have just defined in the class names. All right. So after x6, we will use the y-text for y dimensions, and then I will be showing which according to the class names and the conditions that we have defined in the CIFAR 10 dataset, which I am using the IAMShow method. And in IAMShow, I am going to basically define the training images with index I, and we have CMAP plt.cm.binary. I'm using cm.binary. So, and then we have our X label, plt dot X label. Class names we need to define, we just have defined there. And then we need to use the training images with index I and 0. Training labels with the index I, and with the another index we have is just 0. Alright. So, and then the last command is plt dot show. Yes, outside the loop. So basically here we are using matplotlib to create a grid of 16 sample images along with their corresponding labels. This gives us a smaller sneak peek into what our model will learn to recognize. So now basically to speed up the training process, especially if you are working on a less power machine, you can consider reducing the dataset size. So I am using the training images which are 2000 and the testing images which are 4000, and same for the training labels and training images. Sorry, training labels and testing labels also. So basically we are keeping the first 20,000 training images and the first 40,000 testing images. This is an optional step for faster training. Alright, you should basically set the data set which is convenient for your system. And now let's dive into the heart of our image classifier, the convolutional neural network. All right, so here we are using sequential method. All right, and then we are going to add the layers of conv 2D with 32. So basically here we are building our convolutional network. All right, so it has the conditions, and we need I'm using activation is equals to reload. And then input shape, this input shape is 32, and I can write here 32 input shape, 32, 32 and 3. All right. And now I need to add our max pooling to the two dimension. So for this model dot add layers, uh, dot max pooling 2D 2 comma 2 as a dataset. Yes. I need to use the brackets also because it is inside the max pooling 2D. Yes, now it's correct. So I need to again use model.add layers const 2D. So in const 2D, I instead of 32 now, I will be using 64. Here 64, and the set is the same 3 comma 3, and activation reload 3 comma 3, and I need to use the activation is reload. So and after this, I need to again use the model pooling. So instead of writing it again, I can just copy it from above and paste it here. And same with the 64 by 3 comma 3. Yes. Now I need to flatten my layers. So I will be using a layers dot flatten. Uh, Flatten. Good. So now I need to basically I will be using the dense method with the activation review. So for this I need to dense the setting. So model.add layers.dense and add 64 comma, and then I can use activation. The same method I'm using is relu. Now I need to again the use this dense method with instead of 64 I'm using 10, and the activation which is softmax activation. So after that I need to compile my model. So I need to compile the model. So we have used optimizer, and then we need to use the loss. Basically, I'm using the loss parameter as predefined as sparse categorical cross entropy. So make sure you write the correct spelling. Cross entropy. And the matrix, which is matrix that define our matrix, which is accuracy. So here is where the image. So basically, here is where the magic happens. We are building a convolutional network CNN using Keras. This architecture is well suited for a page classification task. Alright, so now it is time to train our model. So now we use model dot fit. So basically we are basically all these training images and training labels. Alright, and we are using the basically the epochs basically after 10. So basically this code will be run 10 times in order to increase the accuracy. Alright, so the more you add the epochs value, the more the system will get the correct result. So I'm using 10 and the validation data set. In this data set, I'm using the testing images and with the testing labels. Alright, so I'm using it validation. Oh, instead of I need to use backspace and then validation data is equals to I'm using the testing images and testing labels. Now we have trained the model on our training data for the epochs and we validate its performance on the testing data. Alright, so during training, the model learned to recognize patterns in the images. Alright, so after training, we need to evaluate our model's performance. So we have defined the loss and accuracy variables in order to evaluate, and then we are using it to appear at our screen when the convolution when this dataset sequential method will run. So its loss and its accuracy will be appearing so you will see that as the epochs will run from 1 to 10, its accuracy will increase and the loss will decrease. So basically the loss here is that if it has made the wrong prediction, so basically it is considered as a loss, and if it is made the right prediction, then it will be considered as the accuracy. So here we can calculate the loss and accuracy of our model on the testing data. These metrics help us to understand how well our image classifier performs. So basically first I need to create a new folder. So in this I'm using image classifier.model. So basically I'm going to copy its path. Alright, so basically if you are using your default directory which all the data will be saved there, so you don't need to put all the path here, but for my case I need to mention the path here that the so basically model will be saved in the correct folder. All right, so you can save your train model to a file to use it later without having to retain it. Alright, similarly, you can load pre-trained models for various applications. Alright, now let's use our trained model to make predictions on new images. Alright, so basically after So basically the images that we are using here, I will be provide the link into the description so you can get 32 by 32 dimension images for the different animals and things that I have used here in order to if you find it difficult to get it from the internet and make it 32 by 32 dimensions, so I will provide the link into the description. You can directly extract the images from there. All right, so let's see what our sample visualization looks like. So basically, so as you can see, the frog, truck, and there everything here is 32 by 32 dimension. You can see that there are things that you cannot tell. So basically, there's an error. So what does it say? Activate. So basically, yes, I have write the wrong activation spelling. Somewhere I need to correct it. Yes, here I forgot to write I here. Now save it and run it again. So yes, in this environment I can also see the memory usage. Uh, So basically, yes, the sample images appear. So these are the sample images. Now it will be basically running for 10 epochs. As you can see, as the program is running, the loss is decreasing and the accuracy is increasing. Alright, so basically it will be running till 10. So it is the first epoch, and when it is completed, the second one will be started. So basically it is a long process. So I will be see you in the next when the epochs will be completed. So now the epochs has been completed. So we can see that the loss is 1.045 and the accuracy is 0.6. So basically the accuracy, which is 0.6, it is perfect for us. We can directly detect the images by 0.6 accuracy. It is approximately 63%. So basically now it is the data set that I will be provided that I will provide its link into the description, so you can directly extract it from there. All right. So uh, now let's just download it into my system. Extract, or I can just also copy instead of extracting the wrong process. Yes, I can just paste it here in my image classifier module. Just refresh it. So we have car there. So basically you can see that it is very difficult to predict because it is 32 by 32 dimension, and we don't know if it is a deer or a car or a plane or a horse. So basically these are the four images that I will be using as my image classifier so that it can predict correctly. Alright. Now it is car, deer, horse and plane. So basically it is 32 by 32 dimension. You can see that. Now let's skip it, cut it. Alright. Now, what we need to do, yes. So basically, in image class, we just yes, first we need to block this code. So I don't want my code to repeat it whenever I run my program. This code will be running 10 epochs, so I don't need it because I already save it into my folder. So my model is already trained, so I don't need to repeat it again and again in order to identify or classify a single image. Alright, so basically we load an image, pre-process it to match the input format expected by our model, and expand its dimensions to make it compatible. Alright, so now it's prediction time. So we can use our model to predict the content of the images. Let's find out what our model thinks the image contains. Alright, so I am using the image variable. Alright, so I'm copy first I will start with car, so I'm just copy the path from here. So it is in JPG format. Alright, so I can write so I can write the car.jpg here. Alright, then after that I need to use .cvt color. So in cvt color method I need to put my image variable. Image is equals to cv.cvt color. Yes, this is the method. image variable, and then we have cv dot color. So basically there are so many variant here. So I need to use the one that I need, bgr 2 GB. Yes, here it is, GB. Let's click it. Now it's I have selected the right color. Now I need to resize my images. So basically, I need to resize with 32 by 32. So basically, we are as we see this, as we saw the sample images. So basically, the images that is required here are 32 by 32. All right, which we have just discussed. So basically, they are less likely to predict by our naked eyes. All right, that is why we need a model. Basically, it can detect the patterns of the images. All right, so it will be more practical this way. Now I can expand its dimension. I am adding basically a batch dimension, so I can expand dimensions, dims, and then my image, and then axis is equals to 0. Now let's perform prediction. So the prediction model dot I can use the predict method, and I need to divide this image into 255 inside the bracket. I need to mhm, now image is 255.0. Now I need to use the index is equals to np dot argmax prediction. It is the argmax basically the method that we use to predict our image. It's time to show the image. All right, first I can print the prediction is the label will also appear. All right, prediction is class names. Now finally we will visualize the image along with the predicted label. All right. So basically we find the class with the highest prediction score and interpret the result. In this case, it tells us what the image is likely representing. So, and then finally we will visualize the image along with the prediction label. And here is the visual proof in PLT. Show cm dot binary. And now I just need to use PLT dot show. Alright. So basically, and here is the visual proof of our model's prediction. So alright, let's run this program. So it is all we have here PLT dot show, and let's check slowly. Uh, Everything looks fine. Let's run this program. Uh, Alright, let's figure this terminal. Let's see read usage. Yes, basically it is evaluating. Here are the sample images that we used as a visualization. We will block it. Yes, here is the car, but it predict correct, but why it is showing the whole class name? Maybe I did something as an error here. Yes, yes. In class names, I need to use the index variable as an index. Now it will work fine. So let's again run this program and wait to predict and to let the model predict the image. So we have used the image of the car. So you can use any other image, but please remember that the image should contain less and less distractions as possible. Alright, so these are the sample images, and it is showing that to enable, yes, the prediction is car. It is showing the correct results. Alright, so let's close it. Alright, so now we don't need it. Uh, Instead, the sample images are appearing again and again. Let's just block this code. We don't need it anymore. So this should the images sample images should not appear now. Let's again run to check. The sample images should not appear directly now. Predict the image that I inserted into the model. Just to enable the following instruction. Yes, TensorFlow is running. Yes, it is showing only the car image, which is the predicted image. This is what I want, that the prediction is car. Now the sample images has gone. Alright, so now let's try with the uh, another image of our uh, plane. Yes, here we write the plane and run this program to check if this model is doing what we want. Wait. Yes, the TensorFlow, yes, the prediction is plain. All right, it has the prediction is correct. So sometimes maybe if you try the same code and the same images, maybe your code will predict something else. But remember, if something like this happen, you need to again run the epochs, because the more epochs run, the higher the accuracy rate will increase. All right. So remember this, if your model is not predicting the correct images, you need to increase its scaling. All right. Let's close it. Yes, but we have inserted the image of the horse. Now the prediction is horse. It is correct. Now our last image is deer. All right. So run it and refresh it. Yes, it is running. Yes, TensorFlow is enabled. Now the prediction is there. Alright, you cannot see the there even by your naked eyes. Alright, but the model can predict it because it reads pattern. That's it for today's tutorial. I hope you found this explanation helpful and that it demystified the process of building an image classifier in Python. So guys, thank you for joining us today. Be sure to check the video description for all the relevant links including the code and dataset. If you found this tutorial helpful, please give it a thumbs up, subscribe to our channel and hit that notification bell so you never miss an update. We will see you in the next video. Thank you.